Hello, and welcome to the final video about DataForge for the Advanced Software Engineering class at Full Sail University. The core component of today's video is about the unit testing that I implemented during this final assignment. I'm here to show you today 12 unique functions that I implemented as part of the unit testing. Each of them tests a specific component of the application. I created 4 specific classes that use the NUnit version 3 testing framework. The core components that I chose to test are the code generation manager, the message definition class, which is shown here, the message items class, shown here, and on the left you can see its testing class that I wrote. On the right, again, we have node extensions and its tests, and the code generation manager. We will go ahead and show you from a fresh clean the solution cleaning, and then we will build the solution for both the DataForge application and the DataForge testing application that I wrote to pair with it. As we can see, both of them succeeded down here at the bottom. Now we will go ahead and start by running these tests. We can open this test explorer. We can see that while there are about 12 functions that I implemented, if we clean the application again real quick, I can show you that before building, it detects that there are 12 individual functions, which we will go through here in a minute. These 12 functions encompass the entire test that I am running, and each of them have additional parameters that are developed at compile time so that we can test more robustly the application that I wrote. That comes out to a total of 57 tests. If we go ahead and click this Run All Tests in View, we will see that they have currently all failed, and that is because I plugged in some individual cases per test that would cause it to fail. If we start with the code generation manager tests, as this is the first window here, we can look and see that the prepare code definition test, which involves a setup of creating a code generation manager, the compile units, the code provider, in this case the test was done in C#, and the code namespace that we will be working in. In this case, the code generation will add a namespace called DataForge test. We then created some new messages that are defined at a one-time setup. This means that at the beginning of this testing class, we set this up with these class objects, and then it will be used from that point on. And then at the end of this class, we will tear down, and we are required to manually dispose of the code DOM provider at the end of a testing setup. That is something that they require as part of the code DOM provider test utilities. The prepare code definitions test is the test for this function here for preparing the code definitions. It is the function that I created recently that makes sure to add all of the messages that we have defined from our message definition list into a namespace that is usable by the code generator. It looks for a specific set of messages to follow this format, where we have two objects, object 1 and object 2, and then var 1, 2, and 3 for each one of them with separate types. Then we verify that those did in fact get created as a definition in the types in their specific locations by comparing the names of every object. We first double check that there are enough namespaces created, that there is only one namespace created, and that there are two types, which are these object types, added to it. On the right here, we can see I added a function here, or a code line, to make an example NUnit fail case. In the case that we're adding this function, and we've made these tests, and the tests are already here, but we're implementing the function now because we were using a specs style. What happens is, in the case here, we expect it to be a setup of one member per class, and they need to be in this specific order. But in the case of here on the right, we accidentally added it twice. And that could have happened from copying and pasting as a mistake. And so if we go ahead and remove this, We can then right-click here and go ahead and say run tests again, and it will run for this specific function. It did not run for this function, so maybe we'll run it over here instead. Let's see. It says it partly failed because we're still working on creating the rest of these to succeed. But we can see that that specific test for only this function worked. But over here we'll see that there's one of two passing, and that is because the next section, which is testing the generating the code to fail test, uses this prepare code definitions function. In the case of why this failed here, we simply forgot to add that code into the message. We forgot to prepare the code definitions as part of the code generation. So what we can do now is we can add this back in, save the file, let everything build, and run this test again. We can see that it still failed because I did not do something else. Let's see, 1 second. Build, succeed, run this code, run the test. One test passed. This test failed. Insert that it equals this. Expected output is that. What does it say that we got though? That was private var log basic item types. Right. This is because this test also overlaps with another function that is broken. As we can see here on the right, the code generated, and it did generate the code, but it's using a bad data type. And that is because other parts of this code are also broken. So we need to go and look and see why this code has failed. And it looks like it's failing because of message types here. So what we can go and look at is we can go over to message items, and we'll open up that class. Message items has several things in here that are broken. One is that the string tests fail because we have a typo in creating the string types. When we use the toString function, which creates a special label to display to the user for this variable so they can get a good preview of what's in it, we accidentally put an extra colon. So if we go ahead and remove that, and we fix that typo, and we fix it again here because we copied and pasted. And then we'll also go ahead and run into this and see that we misunderstood how to get the basic type, which is a type that the variable is declared as. Normally, when we run code generation, we need to have an actual valid type, like a C# type that represents that object. And it can be a custom type, or it can be a basic type. And in this case, when we're getting the basic type, somebody improperly expected the value to be a function call here, where we can say this.basic_type get type. What that does is it does return a type, so this is a valid function, but it does not return the type that is related to the selected basic type. It instead ends up returning this basic type enum type instead of what the assigned value is. So we can fix that by creating this proper setup, which is going through the list of the enums, and then we can return the correct type. Now, when we save and run both of these tests, we should see that if we run all of the message item tests, that they all pass now. Yep, every single one of these passes because we fixed these typos. If we go back to the message definitions test, the code generation test, it should hopefully run and succeed now, which it did. The only things we need to look at real quick now are the node extension tests to find out why these are failing. And that is because we accidentally messed them up in code. In this case, when we were trying to move the node up, we failed to insert the node at a previous index. We actually just inserted the node back in the same location, and that will not work. So we can correct that. And the move down function did something similar. And in this case, because these functions look very similar, it's highly likely that somebody copied and pasted the move up function to the move down and then failed to change this insert position. And as such, it now does not insert the node in the correct location. We can correct that by putting my code back the way it was. And then we can run those tests by right-clicking down here and run. Now we'll see they all succeeded. And then the last thing to look at is the message definition tests, which are currently failing. The reason they are failing, if we look at the message definition, is, oh, it looks like another typo. We accidentally put a semicolon in here instead of nothing, because this is a special custom class type. We don't add any additional attributes to the definition of the toString, and so it just needs to be an empty string, which this code can even be simplified to just being it equals this dot name, and then we return. Or we could even just return this dot name if we were doing even more code refactoring. The child nodes, we were trying to do a cool trick where we incremented here so that it would automatically increment, and perhaps this was a while loop that then got turned into a for loop, and we failed to remove this plus plus. So it's then adding the wrong message to the wrong location in these child nodes. Now that we've corrected those, if we run, we can now see that the code is generating and everything is succeeding. All 57 tests pass. Now, what are these 57 tests? A lot of them are really important tests. Some of them are verifying that if we create a random set of strings for these toString tests, we go ahead and we create 10 of them, and then we check that all 10 of those can become a valid structure name, or they are at least not going to break the application. In the message item tests, we have multiple functions that are very long. In the case that we're creating a complex type, we need to verify that we can handle underscore class types, camel-cased class types with a space in them, or being given no class name. And then the additional thing is here we have values with the basic enums, and we also have the option for each of them to be an unsigned value. So to simplify the testing, we create one function, but we then pass in this NUnit flag that says that we are using values of all the values of basic enum, and we're also using a list of true and false to toggle this boolean between each one. So this results in a very large multi-dimensional array that we can look at in the get basic types. We can see that it generated 18 of these tests in here during compile time. That helps us make sure that every single one of these types works. We also have a get nodes function of all types here. So if we go to the message definition tests and we look at that function, we can also verify that if we insert a whole bunch of items into the tree and then get those out, that every single one of them is equal to its appropriate type. And this allows us, this function here goes through every single basic enum type and make sure that if we add these message items to the tree, then get their child nodes, they return the proper toString expected format. And that is all. I'm sorry that I spoke so fast, but it's a lot of content to go over, and I honestly didn't have a lot of time today. If you have any questions, please let me know, and I will get back to you, and I look forward to hearing from you. Thank you.